Good day everyone. So for today's video, tuturuan ko kayo kung paano gamitin ng maayos yung package na ginawa ko for computation of heat transfer concept. So to begin with, let's open our Jupyter Notebook. So after installing properly the package, make sure that you open your Jupyter Notebook in the same directory as the package to avoid error. And as you can see in this app, we have here a syntax, and just copy this syntax in order to import the package. And this package include calculation of radiative heat transfer, heat exchanger, and the weight max wavelength. So for the first problem, we have the calculation of radiative heat transfer. So we have the problem statement. Consider a spacecraft with a metallic surface area of 12 meters squared. The emissivity of the material is 0.85 and the temperature of the spacecraft surface is around 300 Kelvin and blah blah blah. Right after understanding the given values, we assign the emissivity, the surface area, the temperature of the body, the temperature of the surrounding, and a few factors. Right after assigning all the given values, we can able to calculate it and to get the desired amount we want. And we can now use the function to calculate the radiative heat transfer. And the radiative heat transfer, it should include emissivity, surface area, temperature body, temperature surroundings, and view factor. And make sure that the order of these givens are properly labeled and on their proper places to calculate it properly. And in order to get the heat transfer or the heat values, we can now print it using this syntax here and just copy it in order to get the exact amount we want to get. So for our second problem, we have the calculation of heat using LMTD method. So once again, we're given a problem statement and we should analyze it in order to get the necessary given values to get the heat value. So the the values we should get are the mass flow rate of both cold and hot fluid, the specific heat capacity, the inlet and outlet temperature of both hot and cold fluid, the overall heat transfer coefficient, and the surface area of heat exchangers. Right after getting all those necessary given values, we can now able to evaluate the problem and get the heat. And to calculate for the heat or to get the desired amount of heat, we can now use the function, which is the heat exchanger heat transfer. And it should include the method, which is the LMTD, the mass flow rate, specific heat capacity, the inlet and outlet temperature, the overall heat transfer coefficient, and surface area of heat exchanger. And make sure that the arrangements are once again in properly placed. And to to print the value, we can use this syntax here, the print and heat transfer rate in LMT method. And then we can run the code, and it should um, result to 1,061,273.38 watts. So for our last problem, so for calculation of Wien's displacement law. So lastly, we were given a problem statement, and the only important given is the temperature. So we assign the value of temperature, and here we have 5,000 Kelvin. And once again, we can now calculate for the maximum wavelength in both meters and inches units. So we can now use the function and we imported and use the print function in the Jupyter notebook. And once we run the code, we should be able to get the maximum wavelength in both meters and inches unit. So that's the demonstration for the package I created, and I hope you were able to understand on how to properly use the package and all the function. Thank you for listening and thank you for watching.